Hello everyone. The next concept is program counter. Suppose I am going to be say about the program counter. It is not possible to understand directly. Hence, I am going to be change the title of this concept as a basic operational concepts. That means here I would like to explain how a computer can execute the instructions. So, before I am going to be discussing something, I would like to explain that we are going to be consider program. So, we know that a program is a set of instructions. For example, the first instruction is A plus B. The second instruction is A is C into D. The third instruction is E by F. So here we are going to be consider three operations are performed in a program. Or one more simple example. Now I'm going to consider value of A equal to 5, value of B equal to 6, and I'm going to perform C equal to A plus B. That means we are adding the two values, value of A and value of B, and we transfer the result to the C. And I simply write print C. That means the C is displayed on the screen for the user. So this is known as a program. In this program, each and every step is known as the instruction. Now I am going to be bifurcate this one. What is an instruction? An instruction is simply a set of operations or a single operation. For example, let we consider that I am going to be a equal to 5 means I assign a value is 5. So I am going to write C equal to A plus B means there are the two operations. The first operation is adding A and B values, that is 5 plus 6, that equal to 11, and after that the 11 value is stored in C, that is C is assigned to 11. So this one instruction consisting of the two operations. So here we know that what is a program and what is the instruction. Now I would like to explain what is the software. Simply the software is a set of programs. Now we conclude that and write all these things within a particular order. So the top level is the software. The software is a set of programs. The program is a set of instructions, instructions, and an instruction is a set of operations. So this is the one of the fundamental issue when we are discussing about the programming. And now I come to the next concept, that is in a program. Suppose let us consider this is a program. Right? This is the second topic, second point. The set of instructions are like that. So this is the first instruction, second instruction, third instruction, fourth, fifth, and so on. There are n number of instructions. All these instructions in a program are executed in top to bottom in a sequential order. Top to bottom in a sequential order until unless we are going to be change the execution sequence. This is also known as program execution sequence or simply program control. We should remember these two things before we discussing in detail about the basic operations of the computer. The third point is also we should remember is we know that in a computer the main part is the processor. The main part is the processor. The processor may also consisting of some small storage, not memory, some small storage units. Those are known as the registers. This is the point 3 we should know before we are understanding this basic operation. Again, these registers are two types. One is the general purpose registers. The second one is the special purpose registers. The general purpose registers are shown with the names with the capital letter R. Suppose there are n number of registers. The first one is the R1, R2, and so on, Rn. N number of registers. The special purpose register has the names specifically. They can represent certain function or operation to be performed. For working of a computer, at least we required 8 special purpose registers. So the special purpose registers or general purpose registers both are resides in the processor. So let us consider this is the processor. This is the register R1 general purpose register. This is register R2. There are some special purpose register. This is the accumulator, and this is the PC program counter. This is the IR instruction register, like that. So the 8 special purpose registers I am going to be represent here as the first one is the PC. This is the full form. This one is the program counter. This is our concept heading. The second one is the AR. The full form is address register. The third one is the IR, known as the instruction register. The fourth one is the DR, known as data register. The fifth one is the TR, known as temporary register. The sixth one is the AC, known as accumulator or processing register. This is the one of the important register. All operations within ALU and within AC are performed. Suppose this is known as the ALU. Within ALU, there is a register known as accumulator. Operations are performed in the accumulator. And the seventh one is the INPR, known as input register. The eighth one is the OUTR, known as output register. So these are the registers thus have by the a basic computer. Now we start our discussion based on the before 3 points we are discussed. That is, we know that the program is a set of instructions. This is the first instruction. This is second instruction. This is third instruction. This is fourth instruction. This is fifth instruction. This is sixth instruction. All these instructions are stored in the memory. Memory means main memory. The memory is like that. We are already discussed, like the locations, and each and every location has a specific number known as the address. For example, this is 101, 102, 103, 104, 105, and 106. In 101, instruction 1 is there. In 102, instruction 2. In 103, instruction 3, instruction 4, instruction 5, and instruction 6, and so on. So the program is stored. We know that the program executes from top to bottom and in a sequential order. How the processor, how the processor will know the starting address of the program, right? So now I am going to be take one more document, right? Please wait. So this is the once again I draw this one here in the memory, right? In the memory, the program is resides like 101, 102, 103, 104, 105, 106, and 107. So the processor is there. How the processor will know this one? So the starting address of the program, that means the address of the instruction, is available automatically in a program counter register. So the program counter has 101. So this is the starting address of the program. We know that that is the first instruction, second, third, and fourth, and fifth, and so on. So after that, the content of the program counter is transferred to the content of the address register AR. So the 101 is transferred to the address register, right? Whenever the content is transferred to the address register, the program counter will automatically incremented by the next address, that is next instruction address, that is 102, right? So by using this address within the address register, we go to the memory, right? We go to the memory and we fetch the instruction, the first instruction, and keep it in the instruction register IR. So this is IR. We fetch the instruction, we go to the memory and fetch the instruction and keep it in IR. Let us consider this instruction is A and B. So where A is the certain value and B is the certain value. Again, by using the addresses of A and B, we are fetch the data of the A and B into the data register. For example, that may be 4 or 5, right? Now, by combining the instruction within the instruction register and data within the data register, we transfer this content to the accumulate register AC within the processor. So in AC, we combine this one 4 plus 5. The operation is performed in the AC because we already know that AC is known as a processing register 9. So the operation is performed. After completion of the operation, again we store back the result into the memory. So this is the suppose basic operational concepts. Once again, I explain that by let us consider 105 is the address of the first instruction, 106 is the address of the value of A equal to 5, and 107 is the value of B equal to 6. So the first address of the instruction is available in program counter 105. This instruction, this address is transferred to the address register 105. Whenever the value from program counter is transferred to the address register, the program counter value is incremented to the address of the next instruction simply by 1, that equal to 106. By using this address, we fetch this instruction from the memory and keep it in the instruction register IR, that equal to A plus B. Now, the computer can analyze this instruction, what kind of the operation to be performed, and fetch the data again by using the A means 106. Again, the 106 is come here. Now, we fetch the data value of A and keep it in the data register, right, that equal to 5. The again the program counter is incremented 1. After that, again 107 is transferred to the address register. We fetch the data 6 to the data register. So the analyzer instruction and the data is transferred to the accum register and operation is performed, that equal to 11. After completion of this processing, again we store back the results in the location of the memory 108 here. So this is the basic operational concepts and also about the program counter. Thank you.